calculating probabilities using the binomial formula. So we're looking at this method. These methods follow in their own separate videos. The formula is here in the Edexcel formula book, so it doesn't need to be memorized. N is the number of trials. So let's say we're doing an experiment with 10 trials, and the probability of success, P, is 0.6, and we're looking for the probability of 7 successes in those 10 trials. So here is the calculation that we want to do, and on our calculator we enter the first part as 10, then press shift. We want the NCR function, 10C7, this part, times, and that's not a fraction, 0.6 to the power of 7 times 1 minus 0.6 to the power of 10 minus 7. So here's the answer to the question where if you have 10 trials and you're looking for exactly 7 successes in those 10 trials, and where the probability of success in one trial is 0.6, the answer is 0.215 to 3 significant figures. Question 1. So what does this binomial distribution exactly tell us? It's telling us that we've done something 5 times, there are 5 trials, and the probability of success in any one of those trials is 0.15, and x is a discrete random variable that represents the number of successes in those 5 trials. So x could be any value between 0 and 5. So our first probability, what's the probability we had no success? So x was equal to 0. And again we just use the binomial formula. So n, which is 5, and x, which is 0, times p, 0.15, to the power of x, open brackets, 1 minus p, close brackets, to the power of n minus x. And just follow the formula in the formula book. Enter the values into your calculator. I'm using 4 significant figures here because I may want to use this probability for subsequent calculations. If this was just the final answer and I'm not using it again, then 0.444 would be fine to 3 significant figures. Okay, part B, to work out the probability of exactly 1 success in those 5 trials. Again we just use the formula, and this time x here in the formula is equal to 1, and we have our probability. Part C, to work out the probability of exactly 2 successes. So this time our x value is 2. The rest of the values in the formula remain the same, and here's the answer. So px is equal to something is very straightforward to work out using the binomial formula, and you don't need to memorize it, it's in the formula book. Now part D is a little bit different. I want to work out the probability of x less than or equal to 1, so the number of successes is at most 1. So x could be 0 or x could be 1. So I need to know the probability that x is 0, I need to know the probability that x equals 1, and we've already worked those out here and here. So we just need to add them together. So probability that x equals 0 plus px equals 1, add them together, and here's the final answer. I've rounded to 3 significant figures this time. Then part E, the probability of at most 2 successes. So we want the 0, the 1, and we want the 2. So we add up all of those probabilities. We've got 0 and 1 here, 2 is right there, add them together, and we get 0.973. For practice, try these questions, but make sure you're using the binomial formula to answer these questions to get practice using this method. And remember, sometimes we have to use a formula-based approach because some values are unknown in a problem that do not allow you to use your calculator's built-in statistical functions. The calculator methods are always the quickest, quicker than the formula method here. But if there was some unknown value that prevented you from using the calculator's built-in statistical functions, then you will have to use the formula. So answer these questions only using the formula.